Hi, it's KC2IRV again. I wanted to make a quick video with some recent discoveries in my simulcast project. Last video I made, I was talking about having to build a couple of circuits to take care of stripping off the PL and inserting it on a different port and de-emphasis and so on and so forth. Well, I think I found how to get flat audio in my Kenwood TKR-740. Anyway, I did build one of the circuits. It's ready to go. This is actually the low-pass filter and buffer circuit using an LM358. I believe it's an LM358. Yep, LM358. So I built that, and that works great actually. It's actually using the second order filter method. So, and actually there's a website that has some really good information on it. If I can find it here. So, I should printed it out. Website on second order filters from electronics-tutorials.ws. They have some really good write-ups on active filters and stuff like that. So if you want to check them out, it's a very informative. Definitely taught me a few things that I did not know about filters and some better ways to do things. So anyway, besides that, back to the Kenwood. So anyway, I was looking through the schematic, and this is going to be very informal. Let's go over to my computer here. This is the Kenwood schematic. Alright. I'm doing this all on my phone, so forgive me. They actually use a separate phase lock loop circuit for the sub-audible tone. The tone comes in here. You can actually see it says sub mod right there. And that's where that comes from, that TD input. Well, anyway, I noticed when I went up. I'm trying to do this around the phone, and it's interesting. Went up, and this black line here on the left is the regular modulation line that comes from the transmit audio. And there's a test point, mod, right there. And that goes directly to these varactor diodes that modulate the VCOs. And I said, I wonder what would happen if I injected a signal on those varactors. And sure enough, I am able to directly modulate. So this is a schematic actually from a TK-740, but the schematic's pretty much identical. So I injected tone right on that modulation test point, which is right down there. And lo and behold, I have a flat audio input from, DC up to, 5K. So let's go show you an example of that. Let me go over here. Just getting a tour of my very messy upstairs. So here we go. I've got my generator set to, right now I got it set to about 3.3K. So let's bring it down to the sub-audible level. So about ish. That's sub-audible. And where's my thing? There it is. There's my probe. So TKR is on. Put that there. And if you look down, this is in the transmit portion. Let's see if I can get some more light in here. It's going to be interesting. There's that little mod test point. There's also the mic test point too, which actually works as well. But the mod test point's right there. And watch what happens when I put my probe on it. Got the probe on it. Oops. So I got the probe on it. I don't know if I can keep it there. This is going to be interesting. Very interesting. So, see if I can key this thing. Stay, please stay. This is going to be an interesting video of me trying to get this thing to stay. Oh, there it is. Look at that. Modulating at 1.5K. That's a subaudible tone right there at 169 hertz. You know, without that limitation of 3/4 of a kilohertz. Okay, and then if I bump that up, I'm at, let's see here. Oh, that's my meter telling me it's going to shut off. There's like 4K. Yep. Frequency falls off a little bit, but from about 400 hertz up to 4K, it's pretty flat. From the subaudible up to around 400 or 500 hertz, you actually get a little high frequency fall off. But there you go. That solves my problem. Essentially solves my problem. And it's an easy to get to point. You don't have to heavily modify the radio. I don't have to monkey around with all those op amps and circuits and stuff. And it solves my problem. So if anyone else is trying to use these with the All-Star RTCM to generate PL tones and having that same issue I have with, you know, having the audio mixed on one port from out of the RTCM, you can now inject that audio into this mod port, and it will modulate the transmitter as if it's a flat audio input. So I tested it with a square wave, and it's square enough, which I think actually my probe might have more to do with it than anything. So let me see something here. Let me bring this down. Okay, I'm down around 800 hertz. And get my probe. I really need to buy a better camera. I have another camera on a tripod. So okay, we're on there. So now if I hit transmit, there's my square wave. It's square enough. Let me do that. Square enough. Got a little bit of a ring to it, a little tiny bit, but I think that's due to my probe, the compensation on my probe. So, can't ask for better than that. One of my gold standards is the 400 hertz square wave. If you can pass a 400 hertz square wave through it, you can pass pretty much freaking anything. So let's do that. Let's do that test here. So got a 400 hertz on the generator, and there it is. Like I said, it's got a little bit of a ring to it, but I tell you, that's a beautiful sight right there. Like I said, I think that ring's due to my probe. So, but there you go. I have solved my problem on a whim. I just kind of a last-ditch effort because I got tired of monkeying around with all this stuff. You know, a lot of work. I mean, even just to build something like this, just the soldering with this and stuff, it takes time. You know, and to test it out, and so if I can do the same job without having to kind of reinvent the wheel, I'm all for it. I actually just got the RTCM to actually connect to the host the other day with the help of somebody on the AppRPT mailing list. And I also found out another piece of information, that the RTCM wants to see a 5-volt peak-to-peak, 1 pulse per second input, and not 3.3. Apparently 3.3 does not work. And my, Chinese GPS DO only outputs a 3.3 volt signal, which was kind of a bother. Well, I was experimenting with I bought one here. Let me get it. There we are. Here we are. This is the, let me turn it the right way. QRP Labs QL G1 GPS receiver module. which gives you 1 pulse per second out, and the NEMA data. So there's a little patch antenna they give you. I kind of put this together a little backwards, but anyway, I noticed in the schematic, it's 2.8 volts coming out of here for the 1 pulse per second and the serial data, and they're using this. It's a quad AND logic chip, which actually this specific chip is no longer available. There is a one from Texas Instruments, and all they do is this is a level shift, and mainly because this a high on this is about it's about 2 to 3 volts is a high, and about it's like 0.8 to like 1.5 volts for a low. And then if you have a V sub CC on this of about 5.5 volts, it'll give you a 5 volt output for your 1 pulse per second. So I got a couple of those on order, and I'm going to try that out, and hopefully I'll have working GPS working on the RTCM. I'm going to probably write a schematic out for that, and share that with you when I'm done, and show you the testing. So once again, you have any questions, any comments, let me know. I'm all ears. It's Casey2RV, and talk to you later.